Hello, hello. So this is gonna be quick, hopefully quick, video on area models and area models that can be written as an expression, and then from that expression written into a algebraic phrase. Um, so an area model is basically, how do you find the area of a rectangle? So you find the area of a rectangle by length times width, or width times length. So this times this would give you the area of the inside of this rectangle. And in this case, that's why it's called an area model. So in this area model, we have a width of 2 and a length of 3. So this expression, now I don't want to actually solve this. This expression would just be 2 times 3. That's the expression that is represented here, 2 times 3. Now the answer would obviously be 6. That's the area, right? If I was to divide this up into the sections it says, there would be 1, 2, 3, 4, 5, 6 sections, right? The area is 6. But the expression itself is just 2 times 3. And the phrase of that is, you could say maybe 2 times 3. Another one could be the product of 2 and 3, or maybe 2 multiplied by 3. Ooh, I don't want to mix. Don't want to mix numbers and words. All right, if you're going to use numbers, use just numbers. If you're going to use words, use just words. I messed up. My bad. So 2 multiplied by 3. So here is 3 different examples of the phrase that is represented by this area model. And this is the expression itself that is represented by that area model. So in this next example, we have a width of n. Don't know what n is. It's some number. It's a number. Don't know what it is. And a length of 3. So, I'm going to yawn. I'm going to yawn. Whew, long day. All right. So the expression represented by this is 3n. Now, not n3, so we would not do this. We do not do that. All right, we put numbers in front of the variables called a coefficient. So the coefficient of this term is 3. So this is the expression, 3n. Now, what's one way that we could phrase this out? Well, we don't know what n is. N is a number. So that's what we're going to say. A number times 3. Or maybe we could do triple a number. Triple means to multiply by 3. I think that works. Triple a number, 3n. What about the product? Wow, I just need to, I think, it's been a long day. The product of a number, oh my gosh, slash, guys, this is not an English teacher. No more mistakes from now on. The product of a number and 3. You could also do the vice versa of that, as you could do the product of 3 and a number. So all these, 1, 2, 3, 4, there's probably a couple more different ways you can write it out. You do a number times 3, 3 multiplied by a number. There's a few more ways you could word it, a few more ways you could phrase it. But there's no other way to write the expression. That is the expression. That's the expression represented by this. There's different ways to phrase that, but that is the expression represented by this area model. All right, let's move on. 3 more examples. Getting a little more difficult as we go. So this one, this is an expression. Well, they're both expressions multiplied by each other to create a new expression. But this one has 2 terms. We have an n and a plus 3, a positive 3. So when writing out this expression, does it make more sense to do n plus 3 times -5, or does it make more sense to just do -5 times n plus 3? I feel like this one makes more sense than that one. Now remember, this is a multiplication table, so we're multiplying, and we're multiplying this whole thing times this whole thing. But I really don't like that. That's not as simplified or pretty to look at than that. So let's not do that. Let's get rid of, we're not doing or. This is it. This is what we want. That's the expression. Okay, that's the expression represented by this. Even though this comes first, we're going to flip it around so that it's nice and neat, and that is the expression represented by this. All right, so now let's do some phrases. I'm going to do one phrase. I don't want to do a couple phrases. I'm just going to do one phrase from now on. If you think of another one, good on you. Good on you. So I would say that this is multiplication here. So I'm going to go with the product. So the product of -5 and, well, what is happening inside? So what's happening here? Well, what's happening there is a sum. Addition, a sum. So the product of -5 and the sum of a number, because I don't know what n is, a number, and 3. Now, are there different ways to write this? Yes, there are different ways to write this. There are other phrases. However, this is the expression that goes with this area model. That's the expression that goes with this area model. The product of -5 and the sum of, oh my gosh, and the sum of a number and 3. All right, I like that one. You could do the product, or you could do the sum of a number and 3 multiplied by -5 or times -5. There's other ways you can word it, but that's the expression represented by that area model. Moving on. All right, this one. So we're going to take this whole thing, and we're going to multiply it by this whole thing, and we would get n times n minus 3. I like it. That's the way this should be written. So, an expression. So again, we got a product. So the product of, well, I don't know what n is. So the product of a number and, okay, now this one, what's happening on the inside here is a difference. So, and the difference, okay, so issue here. We have an issue here. Oh, wow, difference. Guys, I can't spell. I can't do it. Can't do it. It's no bueno. I'm not good at it. I am not good at being an English teacher. Okay, So we have the product of a number and the difference of what? What is special about this n and this n? Oh, they're both n's. They're the same number. They're the same variable, which means they are the same number. Whatever you plug in for this n, you plug in for this n. They're the same number. So if I say the product of a number and the difference of a number and 3, well, that would be a different number. But we want the same number because this is the same number as this number. So the product of a number and the difference of the same number and 3. So you have the product of a number and the difference of the same number and 3, right? Because the point of this is this n and this n are the same number. They're the same number. So the product of a number and the difference of the same number and 3. All right. Little confusing, little wordy. I'm not a fan. I don't like writing sentences. Obviously, I don't like writing sentences. Gosh, I'm usually not this bad. All right, let's try and do another one. It's the last one. We got this whole thing times this whole thing. So we would get n plus 11 times 2n plus 4. Now this would be just plain old ridiculous. If I was to phrase this, it would just be quite ridiculous. But we're going to do it anyways. All right. So the main thing, the first thing that you always want to start with is you want to work backwards. So the big thing that's connecting these two expressions is multiplication. So we're going to start off with the product. Well, the product of what? What two things are we multiplying? Well, this over here is a sum. And so is this. This is a sum. The problem is within this sum we have something else special. But for now, this one we can write out. So we have the product of the sum of a number and 11 and the sum of, okay, well, what's the second sum? So we did the first sum, we did this, now we need to do this. So the product of the sum of a number and 11 and the sum of, okay, well, this is a sum of what? Well, this is a sum of the product of 2 and a number and 4. That's a little wordy. And plus, I already have the word product. Do I want to put product in there twice? Let's switch it up. Maybe I don't want to use the word product twice. Maybe I put in and the sum of 2 times the same number and 4. I like that. So again, this n and this n are the same. So when I say a number, I have to, the next time I use it, say the same number. All right. And here we have this sum, which is the sum of a number and 11. And then here we have the sum of 2 times a number, the same number, and 4. So the sum of 2 times a number, 2 times the same number, and 4. And the whole thing is connected by multiplication, which is the product of both of them connected. Wow, lots of stuff. I'm not ever gonna, I mean, I wouldn't give that to a student. To phrase, I would want you to be able to get that. The expression you should be able to do. The expression you should be able to do for sure. I think many teachers, especially even high school teachers, would be able to expect that from an area model, you can get this type of expression. Do I expect you to be able to phrase it out like that? Probably not. Probably expect you to be able to do this one, you know, maybe without the spelling errors. Maybe that's a little hypocritical of me as a teacher, but hopefully no spelling errors. But yeah, I'm gonna end it there. This video is not on how to solve an area model. This video is how to create an expression from an area model. So you get the expression from the area model. You just set up a product. All of them are products. An area model is a product. It is a multiplication table. That's how you find area, length times width. Set it up. Don't actually solve it. Don't simplify it. Just set it up. This times this. This times this. This times this. Sometimes you need to put this part in front of this part. Even though we go from left to right, sometimes that needs to go in front, like here. All right, well, I hope this video was helpful to whoever watched this. I might have said more than I needed to. I definitely made more mistakes than I needed to make, which I should be making 0 if I'm gonna post this on YouTube. But I think it's good that students understand that mistakes happen and teachers make them too. So, thank you for watching, and hope you have a great rest of your day.